Hello students, I hope you all are doing good and preparing well for KCET exam. So in today's session, we will be solving questions from definite integral chapter. So before we start with the PYQs, I would want to revise the standard properties that we use for definite integrals. Okay, so one more thing that I want to tell is, so please pause the video and try to solve the question on your own. Okay, if you're not able to, only then look at the solution part. This way you will be able to develop your problem solving skills. Okay, so this topic has a weightage of around 3 to 4 marks. Okay, so you can expect around 3 to 4 marks from this session, from this topic. Okay, so first moving on. So these are some standard properties that you have already learned in your PUC board. Okay, you have already learned them. So the first property that we have is that the variable can be changed. A to b f of x dx is equal to a to b f of t dt. The variable x, they have replaced it with t. And another thing, when the limits are from a to b f of x dx, if I change the limit, it becomes b to a minus of b to a. Okay, this is one thing. And here a to b f of x dx can be broken down into a to c f of x dx plus c to b, where c is in between a and b. Okay, the third property, which is a to b f of x dx is equal to a to b f of a plus b minus x dx. So this is a very important property, very important property. Okay, most of the problems can be solved using this one property. The same property, only it is P4 is nothing but the same as P3. Here we are taking the limits from 0 to a instead of a to b. Okay, then the fifth property that we have is 0 to 2a f of x dx is equal to 0 to a f of x dx plus 0 to a f of 2a minus x dx. Okay, and the sixth property is a result of the fifth property. If 2a minus x is equal to f of x, then we can write the result as 2 times of 0 to a f of x dx. And if 2a minus x is equal to minus f of x, then the definite integral becomes 0 directly. The seventh property, this is another important property. If from minus a to plus a f of x dx, this is equal to 2 times of 0 to a f of x dx if f of x is an even function. So what is an even function? Even function is nothing but when f of minus x is equal to f of x, that is called an even function. When function is an odd function, f of minus x is equal to minus f of x, in that case it is 0. So this is also an important property. So I'll just highlight the important properties. This property, the 0 a to b f of x dx is equal to a to b f of a plus b minus x dx. The P4 and P7, these are most important properties. You can expect a question from here. Okay, most probably. Okay, so moving to the question solving part. Okay, let's start. Okay, so first question. So see, every question of definite integral can be solved using only these 7 properties. Okay, we have to only observe which one of them fits. Okay, okay, so the first question that we have is integral 2 to 8 root of 10 minus x root x plus root of 10 minus x dx. So this is one property that is mostly works. A to b f of x dx is equal to a to b f of a plus b minus x. Let's apply this property. Okay, what do I get? Let me call this as I. Let me call our definite integral as I. I is nothing but 2 to 8 10 minus x root x plus 10 minus x dx. Let me apply the property. Sorry, I have written it infinity, not it is 8. 2 to 8. Sorry, again I'm making a mistake here. I'm so sorry. So here I can replace x with 10 minus x, right? Divided by 10 minus x plus 10 minus x. Okay, what do I get? I get 2 to 8 root x by root of 10 minus x plus root x dx. Okay, I can add these two, 1 and 2, right? What do I get? I get 2y and 1 dx, 2 to 8. Okay, you can check that. So integration of 1 is nothing but x, 2 to 8, 2 to 8 is nothing but 8 minus 2, 8 minus 2 is 6. Our I is equal to 3. So this is how you solve these kind of questions. Okay, this was an easy question, pretty easy question. Correct answer is option D. Okay, so this is how you solve the question. So what did we do? We just applied this property to this question, then we added both the integrals, we got this integral and we simplified both the numerator and denominator got cancelled, and this is how you can solve these kind of questions. Moving on, so this is a similar question, the same property we will be using. So this was asked in 2021. Okay, so I want this to solve from your end. So when you find please put your answer in the comment box. I'll just check that. Okay, so try this on your own and put the answer in the comment section. Okay, so this is an homework. Moving on. Okay, this is an interesting question. Okay, again we'll be using the same property. This is a uh, very popular property. A to b f of x dx is equal to a to b f of a plus b minus x dx. Okay, I'll be applying the same property again here. Let me write it down. Minus pi by 2 pi by 2 cos x 1 plus e power x dx. Okay, let me apply it. The limits remain same, minus pi by 2 to plus pi by 2. What do I get? Cos of 0 minus x, because pi by 2 plus pi minus pi by 2 is 0. 1 plus e power 0 minus x dx. I get minus pi by 2 to plus pi by 2 cos of minus x 1 plus e power minus x. What is cos of minus x? It is cos x, right? Cos x, and I'll take here e power minus x common. I get 1 plus e power x. Okay, so this is the trick that I'm going to play. So now I have taken e power minus x common here. Now this integral becomes e power x cos x by 1 plus e power x. Okay, this is also I, this is also I. This is my 1, this is my 2. If I add 1 and 2, what do I get? 2y cos x plus e power x cos x divided by 1 plus e power x dx. Okay, so it gets cancelled. We are left with only cos x dx. Integration of cos x is nothing but sin x. And what are the limits? Minus pi by 2 to pi by 2. So this is sin pi by 2 minus of sine of minus pi by 2. So this is nothing but 1 plus 1, that is 2. So our I, 2i, what we have got is 2i equal to 2. That means I is equal to 1, right? I is equal to 1. 2i is equal to 2, that means I is equal to 1. So this is how you solve these kind of questions. So what did we do first? We applied the property. We got this, and what we did, we added both of them. We added both the integrals I and I. We got 2i and we simplified. We took e power minus x common in this step. That was an important thing you need to know. So this is the technique that you have to use. So this was asked in 2022. So yes, you can solve it in a minute easily. Okay, moving on. Okay, so this is a similar question to what we did previously. So this was asked in 2017. So when you apply the same property again, what do we get here? Minus pi by 2 dx e power sine of minus x plus 1. So e power sine of minus x, you'll get here e power minus sine x plus 1 dx. Again, what I am going to do is I am going to take e power minus sine x common. I'll get 1 plus e power sine x dx by 1. Now this is my I. Again, I e power minus sine x can be written as e power sine x. This will go in the numerator. In the denominator, I will be left with 1 e power sine x. Again, same thing. Adding both the integrals. I get 1 plus e power sin x divided by 1 plus e power sin x dx. Both gets cancelled. I am left with 1 x. Integration of 1 is x minus pi by 2 to pi by 2. This is nothing but pi, right? Pi by 2 is pi. So I is pi by 2. So this was similar to our previous question. The same technique we applied. Okay, so the correct answer is option C. Okay, moving on. Okay, this is an interesting question. Okay, this was asked in 2021. Okay, so we have got in equal to 0 to pi by 4 tan raised to n x dx, where n is positive integer. Then I10 plus I8 is, okay, let me see what is I10 and I8. I10 plus I8 is nothing but 0 to pi by 4 tan raised to 10, sorry, 10x plus tan raised to 8x dx. Okay, so this is our I10 plus I8. So what can I do? I can take common, right? Here tan power 8x is equal to tan square x plus 1 dx. So yeah, here you can see tan to the power of 8x x square x dx. I can do the substitution here. T equal to tan x dt is equal to dx x square x, right? On substituting this, I'll get t power 8 dt. T power 8 integration is t power 9 by 9. uh, t is nothing but tan x by 9. I'm not changing the limits. 0 to pi by 4. Tan pi by 4, what is tan 45? It is 1. So 1 by 9 is your answer. Tan 0 is 0. So the correct answer is 1 by 9. So this was a pretty easy question. So if you solve it, you'll get, okay. So you don't need any shortcuts, okay. So I suggest don't uh, go behind many shortcuts. Stick to the standard formulas. They will help you a lot, okay. So remembering hundreds of formulas is not going to help you in exam, okay. The conceptual knowledge and the logic behind solving a question, that is important. You should know how to approach a question, how to apply the logic, how to apply the standard formulas. This is going to help you in the exam, and it is going to help you score more marks, okay, not shortcuts, remember. Moving on. Okay, so this is also an interesting question. So you have to apply trigonometry knowledge here. So let me check this. I've got log of sin x plus cos x divided by cos x dx. Okay, so I can divide by cos x. So I get it as tan x plus 1. Everyone agrees? Okay, good. Now what I can do? Okay, I've got log of tan x plus 1. I've got 0 to pi by 4. Okay, I'll apply one property. uh, 0 to, I am applying this property, okay. 0 to a f of x dx is equal to 0 to a f of a minus x dx. This property, I can apply this. I'll just check what happens. 0 to pi by 4 log of tan of pi by 4 minus x plus 1 dx. On expanding this, I get 0 to pi by 4 log of 1 minus tan x 1 plus tan x plus 1 dx. So what is this? 0 to pi by 4, 1 goes there in the numerator. On simplifying this, what do I get? I'm doing it directly, so I get 2 times of 1 plus tan x, right, dx. So on expanding the log, I get 0 to pi by 4 log of 2 minus log of 1 plus tan x. Log of 1 plus tan x is nothing but our question itself, okay. So this part, so I can replace that with I, right. So we are only left with 0 to pi by 4 log 2 dx minus I. So I will go this on my LHS 2y. So integration of log 2, integration of constant is nothing but log 2 x On applying the limits, I get log 2 pi by 4, right? So it is nothing but our I is pi by 8 log 2. Okay, which of the option matches? The correct answer is option D. So this was asked in 2015. So it is a slightly lengthy problem. I can say it might take around 1 minute 20 seconds maybe. Moving on. Okay. What can I do? Looking at the question, what you can see. Okay. I think I can make some substitution here. I have got 1 plus x square and differentiation of tan inverse x is 1 plus x square. Wait, can I do something? Tan, okay, let me just check. X equal to tan t. I'll just substitute this. What do I get? What do I get on substituting this? I'm not changing the limits, okay? I'm keeping the limits same because at the end again I'm replacing my t with x, okay? 1 plus x square dx. So if I put x equal to tan t, what do I get? Log of 1 plus tan t, 1 plus tan square x, tan square t dt. Okay, sorry, it is dx, no? It is dx. It is still dx. So what do I get on differentiating? Let me check. Dx differentiation of tan t is sec square t dt. Okay. What is 1 plus tan square t? It is nothing but sec square, right? Sec square t log of 1 plus tan t. Okay. So what is my dx? Dx is nothing but sec square t dt, right? Sec square gets cancelled. Now I am left with log of 1 plus tan t dt. Okay. So how to integrate this? I already told you, right? So if so actually the limits are different here. If x is equal to tan t, then when x is equal to 1, what is tan t? T is equal to pi by 4, right? And when x is equal to 0, t is equal to 0. So the limits are from 0 to pi by 4. Okay. See, what have we got? This thing we have already solved. Okay. This thing we have already solved in our previous question. So the same thing. Okay. Again, you are going to get the same result. Pi by 8 log 2. So actually they have just twisted it around. Okay. So we got the same thing, right? So you can solve this and check. Okay. So yeah, this comes with practice. You need to practice lot of questions so you will be able to observe these kind of patterns. You can easily identify the patterns. Okay. Moving on. Okay. Pretty straightforward question. 1 plus cos 2x. What comes to your mind at looking at this? 1 plus cos 2x in our trigonometry we have learnt it is nothing but 2 cos square x, right? So let me check. If I substitute 2 cos square x in this, what happens? Pi by 4 to pi by 4 dx 2 cos square x. Okay, what is 1 by cos square x? It is nothing but sec square x. It 2 comes outside dx. What is integration of sec square x? Simple, right? Tan inverse tan x. Integration of sec square x is tan x minus pi by 4 to pi by 4 1 by 2 tan of pi by 4 minus of tan of minus pi by 4. So what do I get? 1 by 2 1 minus of minus 1. So that is nothing but 1, right? The correct answer is option A. So this was pretty easy question. It can easily be solved in under a minute. Moving on. Okay. Yeah. So it looks complicated. Sine raised to 103 whole power x cos 101 x dx. So what can be the answer to this? This is an interesting question. Okay, so limits are from minus a to plus a. The limits are from minus a to plus a. So this equals to 0 when it is an odd function, right? So if I can confirm that it is an odd function, the integral is 0. Okay, so I have to check. So my f of x here is sine of 103 whole power x cos of 101 x, right? What is f of minus x? I have to just replace x with minus sign x, right? So what do I get? Cos of 101 minus x. Okay, so I am writing, I am adding this extra step. Okay, I can write it directly, but for your understanding I have just written this extra step. So what is sine of minus x? Okay, it is minus sine x, right? Okay, minus sine x whole raised to 103. What is cos of minus x? It is nothing but cos x, 101. So what do I get now? I get, it is a odd number. 103 is an odd number, so minus will remain. So sine 103x cos of 101x. This is nothing but minus of f of x. This confirms that it is an odd function because f of minus x is equal to minus f of x. It is an odd function. What happens to an odd function? From minus a to plus a, from minus pi by 4 to pi by 4, it becomes 0. So we did a check and we applied the property. So this is how you solve the question. Okay, moving on. Yeah, this is an interesting question. So minus 5 to 5 modulus x plus 2 dx. Okay, so forget about the modulus. Let's only concentrate on y equal to x plus 2. The approach to solve these questions quickly is graph method. Using graph, you can easily solve this method, these type of questions. So let me plot where x plus 2 comes. For let me take 2 points. Okay, so it becomes easier. X, y. So when x is equal to 0, y is equal to 2. When y is equal to 0, x is equal to minus 2. Right. So I have got 2 points, 0 comma 2 and minus 2 comma 0. Minus 2 comma 0 is here. 0 comma 2 is somewhere here. Okay. So this is my line. But this is a modulus function. Okay. We have got modulus. We have got, this is the graph for x plus 2. But we want for y equal to mod of x plus 2. So how can we change this? The only thing we have to do is wherever it is negative, we have to make it positive. Here it is negative, right? We have to make it positive. So the graph will be like this. Let me erase this. This is not required now, right? So the graph will be like this. Okay. So they are asking us from minus 5 to plus 5. Minus 5 is somewhere here. Plus 5 is somewhere here. So to find the definite integral, all we have to do is we have to find this area, the entire area. That will give us my definite integral. So it is nothing but two triangles. Okay, this length I can find out. This is nothing but 7. This length is 3 units. This length, what is this length? I have to find out. If I put x equal to 5 in the equation, I get this as 7. If I put x equal to minus 5, I get 3. My x equal to minus 5 is minus 3. Minus minus 5 plus 2 is minus 3, but modulus of minus 3 is 3. So this is 3 units only. Okay, so I have got two triangles. I just need to find the area. Half base into height plus half base into height. So 9 by 2 plus 49 by 2. This is nothing but 58 by 2. 2 2s are 4, 2 9s are 18, 29. So the correct answer is option B. So using the graph approach, it is very easy to solve these kind of questions. But if you do it in the limit form, it is going to go lengthy. So this is a very easy trick that you can use to solve questions. Moving on. Okay, so this is also an interesting question. So we have got 0 to pi by 2 tan raised to 7x divided by cot raised to 7x plus tan raised to 7x. We will be using the definite integral property. Yeah, 0 to a f of x is equal to 0 to a f of a minus x. 0 to pi by 2 tan raised to 7x cot raised to 7x plus tan raised to 7x dx. So this is our I. So I'll apply that property. I'll get 0 to pi by 2 tan of pi by 2 minus x cot raised to 7 pi by 2 minus x plus tan of raised to 7 pi by 2 minus x dx. So what do I get? Tan of pi by 2 minus x is nothing but cot of 7 raised to pi by 2 minus x. My denominator, I'll get tan raised to 7. Sorry, this is, I'm so sorry. My eraser is not working. Okay, so this is nothing but cot raised to 7x, tan raised to 7x plus cot raised to 7x. So if I add 1 and 2, what do I get? 2y 1 dx 0 to pi by 2. Integration of 1 is nothing but x, 0 to pi by 2. So my I will become pi by 4. Okay, so the correct answer is option A. So this is how you can solve this type of question. So the only thing what we did was we observed the question, and we saw if f of this, we applied the property and just simplified it. So remember, the properties are very important. So you just need to apply those properties. Okay, moving on. Okay, so for these type of questions, I suggest you to do the graphical method. So we have got an integer, greatest integer function here from 0.2 to 3.5 dx is equal to. Okay, how do you solve this type of question? So we have to plot the our function. Okay, let me plot the function. Okay, I'm so sorry. uh, Chalo, 0. So from 0.2 to 3.5. Okay, so let me just write 1, 2, 3 and 4. Greatest integer function takes the value which is the closest integer less than or equal to. So for these values between 0 and 1, what is the closest integer? It is 0, right? But for 1, it is 1, right? 1, 2, 3, 4. So the again between 1 and 2, the greatest integer function is 1, but at 2 it is 2, right? So between 2 and 3, again it is 2. Okay, and again for 3 and 4 it is 3. So we need to find out from 0.2, it is somewhere here, and till 3.5. 0.2 and 3.5. So we need to find the area. So I can easily find out, right? These are nothing but bunch of rectangles. So area of rectangle can be found out very easily. So I can call this 1, 2 and 3. I need to find the area, and that will give me the definite integral. So what is 1? 1 into 1 plus, these are nothing but rectangles. The width here is 1 for the second part, but my height is 2, plus for the third part my width is 0.5, but my height is 3. So I need to just solve this. 1 plus 2 plus 1.5. So this is nothing but 4.5. So this is how you solve these kind of equations. Okay, so using the graph method, this becomes very easy. Okay, moving on. Okay, again, this is an interesting question. Okay, so we have got 0 to 2 step function. Okay, again we have got a step function, but this time it is x square. Okay, so how to solve these kind of questions? So you know what is an x square graph, right? It is something like this. Okay, so let me call this 1 and this 2. So 1 is here, uh, x, uh, x square mein 1 is 1. So this graph is slightly skewed, but please bear with me, because I'll face an issue if I not. So I have done this purposely. So this is nothing but 4, because x in x square graph, this is x square graph, right? For x equal to 2, x square becomes 4, right? And between 0 to 2, we have to do it between 0 to 2. So we know that integer function, greatest integer function takes the closest integer. Okay, for between 0 and 1, what is the value of greatest integer function? It is 0, right? Let me use another color for that, plotting that, so that it is clear. So between 0 and 1 it is 0. Okay, but between when does x square becomes 2? At x equal to root 2, right? At x equal to root 2 is somewhere here, right? So if I take root 2 here, here it is 2, right? And when does x becomes 3, x square becomes 3 at x equal to root 3, right? So root 3 is somewhere here. So at that point it becomes 3. Okay, 3 and 2. Okay, okay. So between 1 and root 2, what is the value? It takes values, the function takes values between 1 and 2. So what is the closest integer? 1. So the graph is like this, right? And between root 2 and root 3, the function takes values between 2 and 3. So the value of the function is 2, right? And between root 3 and uh, 2, what does the function takes? The function takes 3, right? The value of the function is 3. Between root 3 and 2, the value of the function, the greatest integer function, is 3. Okay, so now what I have to do? I have to just find the area of these rectangles. Okay, let me call them 1, 2 and 3. Okay, so what is the area of the first rectangle? uh, Width is root 2 minus 1. My height is nothing but 1 plus root 3 minus root 2. My height is 2 plus 2. There is some error. I'm so sorry, guys. I'm so sorry, guys. So the third rectangle, there it is 2 minus root 3 times 3. So if I simplify all of this, I get root 2 minus 1 plus 2 root 3 minus 2 root 2 plus 3 2s are 6 minus 3 root 3. I get 5. This 2, this gets minus root 2 and minus root 3. So which of the option matches? The correct answer is option E. So this is how you solve this type of questions. This was a slightly lengthier question. It might take some time. Okay, but this was an interesting question. So using graphical method, this becomes very easy. Okay, so I hope this session was helpful to you. If this was helpful, please like the video, and you can watch other videos in my playlist. There is a playlist called KCET 2023 Mathematics. There you can find PYQ videos of many chapters. I have covered many chapters, and I'm going to cover more chapters in the coming days. Okay, so you can subscribe to my channel so that you don't miss any of my videos. So I would suggest you to keep practicing the exemplar problems, your NCRT book problems. So and all the PYQ, try to solve the PYQ problems. This is going to help you in your examination. Okay, all the best, guys.